Welcome back to Monroe Live, everybody. Today we're going to be going over this image, which we clipped from a video that Tesla showed on April Fool's Day. So they were pulling a CyberTruck down a crash test bed, and then they showed this image, which is underneath through a piece of clear Lexan, and we were able to see the cradle and the suspension, and it's all painted. And you may be wondering why everything's painted different colors. Jordan can actually talk through that because you've studied more crash tests, mostly from IHS and NHTSA, than anyone. So talk about what things are painted, why, and then what we see here.
Yeah, so just kind of breaking down the color array here. So on the green, on the outboard sides, we see the lower control arms. So based on the geometry, these look like forged lower control arms. The red is the primary subframe or the cradle. So this is carrying the suspension, likely a large portion of the drive unit, the gearbox, and so forth, also making primary connections of those control arms inboard to the vehicle structurally. The yellow that you can see, it's technically above the subframe in the Z-axis or vertically in vehicle. Those are the primary longitudinal rails. So that's part of the body in white structure. That's the primary impact structure at the front end of the vehicle. Also what this subframe is going to mount to principally. And then at the leading edge here, we've got these little green pieces, which those are going to be your crush cans. Just looking at them, I'm going to make an assumption that they're likely extruded aluminum, but we'll obviously dive into that when we get it. And then lastly, at the bottom of the subframe, we see this pseudo like X member. You'll notice a lot of X member like geometries in this suspension system, but this piece right here, it's blurry, it's kind of hard to make out. It's painted light, kind of like a baby blue. It looks like a multi-piece stamped steel weldment, if we had to make a guess, which we've seen in the past, and we can talk about that a little bit.
Yeah. Let's talk about the geometry. So this is a really exaggerated X shape, particularly because these mounting locations for the control arms are very far inboard. This is something that the Rivian did to get a lot of travel. So the further inboard those points are, the longer the arm is, the more travel you can get while maintaining decent geometry for your suspension.
Right.
So on the Model 3 and the Model Y, we have a similar shape, and we actually have one on the ground right here. And Jordan, let's stand it up so that we can get the same aspect ratio here. So this big hoop that comes up, and then these two arms that come out, they're pretty much emulated here. Similar material strategy. They're mounting in the middle, here, there, and then at the corners. The same thing's happening here. You can see, I think they're probably mounting here or there, maybe there, there, and most likely you'll have a bolt here or here. You'll tie that into the body and white structure. The front bar is very important for SORB. Now, SORB is small overlap rigid barrier. It's a test where you're engaging 25% of the vehicle. The subframe on the CyberTruck is very wide. It's relatively wide on the Model 3 and the Model Y, but the bar that comes across, this is a solid tube. This needs to be very strong. This one is welded in. It's welded in multiple different places, but what we notice here is this is secured with threaded fasteners. Now, the reason why this is most likely done is because it's a different material. Jordan was making an assumption that you could have a very high strength steel here or a very high strength steel there, and when you have such dissimilar metals, they're hard to weld together. Now, Jordan, what's your take on that?
Yeah, this whole cross member, as Corey mentioned, is super important to SORB to mitigate here as if we lay this down. What it's really doing in most SORB events is, depending on how far outboard, the geometry of the member that it's attaching to on these outboard wings, and the dynamics between the barrier and this corner specifically, this member will either go into compression, meaning it will want to crush cross car as this starts to load up from that barrier, or it will go into tension, which will want to sort of bend these wings down, and this will want to kind of stretch or go into tension, right? So at the end of the day, a perfect SORB event would be if the longitudinal rails and the position of all of these monuments didn't really deviate, right? So you want, ideally, those front longitudinal members, meaning these yellow rails, to maintain perfect congruency from one another. And so what that's going to do is that's going to keep your vehicle rigid in order to get away from the barrier. And if the vehicle goes away from the barrier, naturally the occupant is going to be safer. The other thing that I was kind of thinking, right, so it definitely could be dissimilar material, maybe making it difficult to weld. The other thing may be build process, right? It could very well be, if we look at the cooling module, this whole front end assembly, it's very conventional for an OEM to make this whole front end system, starting with the back end of the cooling module, a module, meaning so it comes in as a fully assembled module or a subassembly, and that gets installed to the vehicle in one large chunk.
And this red piece of steel here could be part of that module, and this could come on after, because you can see it shingles
over the top
or under the bottom, because this is on the bottom.
Correct.
Yeah. Also material choice. You may be out there thinking, I got a CyberTruck ordered, and dang it, the subframe is steel. So steel is oftentimes the best choice when you need a high amount of strength and a decent weight to strength ratio. So we have the Rivian subframe right here, which is astronomically expensive and heavy. It's 25.5 kilograms, and they achieve a lot of the same geometrical constraints here, but at a high weight and cost penalty. This is made with a lot of extrusions and plate aluminum. You can see extrusion, 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 extrusions all over the place. And the Model Y and Model 3 cradle is lighter, even though they're using a heavier material. And so a stamped steel weldment oftentimes is a good choice for a subframe. So we're seeing Tesla use essentially an evolution of the manufacturing processes that we see on their Model 3 and Model Y expanded. This thing's much bigger because it's a bigger vehicle. This rear arm goes way further than you see on a Model 3 or Model Y and farther out. Also, Jordan mentioned mounting provisions for the powertrain. Tesla typically mounts their powertrain up on the body in white, so they'll have one or two mounting two mounting provisions on the body, and then they'll react with a torque strut down in the cradle. We can't see it because we're blocked by the channel that pulls the car down, but I think there is some red sticking out right there, and I believe they'll have a mount or a provision to react the torque from the drive unit. Also, it's a front steer. You can see the steering, the tie rods from the steering rack going out, interacting with the front, and it is not virtual ball. You can see that it's one lower control arm and not two. And Jordan, I know you covered that several times. The Model 3, the Model Y, the Model S, and the Model X are all virtual ball front suspension. This is not.
Right. Yeah, and as we go rearward in vehicle, as I had mentioned, we've got like a lot of like these X geometries, right? So the full cradle, if you were to kind of squint your eyes and look, it looks like one giant X with a few supporting members. Similarly, as we go down, this additional, what looks to be a multi-piece stamped steel weldment, this plate, this member down here, is another X. And so this could be serving several purposes. So one of the things that we've seen people do, namely I can think of like the Audi A8, for example. One of the things that they did with a similar member at the trailing end of the cradle is stabilize those rear cradle mounts, in addition to providing a skid plate or a support structure for road hazards, right? So they may be protecting some of the monuments above this. But I want to point out one thing, and it's when you have relatively long cradle runs, especially cradle runs, when by cradle I mean the red piece here, that have a arc or a curve to them, they're attaching to essentially the apex of that curve, and they're sort of triangulating that structure back to what I'm going to assume is going to be the torque box area, the body structure. And so that's going to help stabilize this entire assembly. In addition, what this is going to do is it creates a interface that we would refer to as double shear. So if you just have a plate and you run a bolt through the plate and there's no additional layers or section between the flange of that bolt and the mounting surface ultimately that the piece is mounted to, what happens is that interface is going to be quite a bit less stable than if you were to actually create some section. Meaning, let's say we had a box and we put a bolt all the way through the box. Now you've got two surfaces that bolt is going to be stabilized by. By doing this, if you were to like look at a Z section, or you were to cut through, I guess right here longitudinally, what you would see is if you just zeroed in on the flanges of each one of the bolts, they would be in different planes. And so by having those bolt flanges or those interfaces in different planes, it's giving it a lot of structural section as you go fore aft in vehicle.
Yeah, and we saw a lot of double shear plates, is what we call them, added to the rear end of front cradles probably for the past 15 years.
For sure.
Even if they were small, where they would double up where the bolt went through, and then they'd have 1, 2, or 3 bolts running into the torque box.
Right.
This is essentially a large double shear plate. Also reminds me of a lot of BMWs we saw. BMWs would use stamped steel front cradles, and they'd oftentimes have a huge stamped steel plate that was in an X that would cross usually the rear of the cradle as well.
For sure.
So this is emulating a lot of what we've seen. I think it's just an evolution, but it's relatively refined. What would you say, Jordan?
Yeah, I don't have any major criticisms. Obviously, it's kind of blurry and it's hard to get a true picture of what they're doing. But at first glance, it looks relatively efficient. I do like that sort of X pattern triangular structure. Generally speaking, they do seem to be quite cost and weight efficient in terms of the final execution when we start measuring weights and so forth. I'm very interested to see, you mentioned BMW, and they do have some examples where they've got an extremely high level of cross-functional integration, meaning one functional component like the steering rack, for example, supplements structure on a cradle. BMW notoriously did this on the F10 platform, so that's the old BMW 5 Series, where the steering rack itself, the casting, was actually supplementing cradle structure. So I'm very curious to see from Tesla, given that they've done giga castings and pretty substantial cross-functional integrations. I'd be really curious to dive further into this, kind of peel open these layers and see what else they did under the hood here.
All right. Well, that's about all we can squeeze out of this one semi-blurry image from that video released by Tesla on Twitter over the weekend. But we hope we enjoyed our Jordan and I's little take on this. And thanks for watching. Jordan, you have anything else to add?
No, can't wait to get into it.
All right. Talk to you later. Bye.
Thanks.